Hello and welcome to the Huawei Fusion Solar app. My name is Robert Layton, I'm the Technical Manager at EcoCorp, and this afternoon I'll be explaining to you how to use your app and gather the information that is necessary. Before I start that, I'll tell you a little bit about the app itself. The app can be downloaded to any smart device that is operating the iOS or the Android operating system. It is specifically not to be used on a PC or laptop. Once our installation team have completed your installation, then they will be more than happy to assist you in downloading the app if necessary and to explain the logon procedure. They will issue you with a username and a password, and it's very important that you make a note of this username and password for future reference. The app itself will give you information overall on the energy that is being produced by your solar panels, the energy that you are consuming within your property at any given time, and therefore, by default, the surplus energy that you will be sending back to your virtual battery / cloud battery. So, let's begin. As you can see in front of you, you have a picture of a house with the solar panels on the roof. The white box here, which is the Huawei inverter, a very sophisticated computer-controlled transformer. You'll also see here a picture of a lamp. The lamp represents all of the electrical loads within the property, regardless. So whether you have a light bulb on or you have all the air conditioning, swimming pool heater, swimming pool, etc., etc., this lamp represents those loads. You'll also notice that there are lines connecting the panels to the inverter here, the inverter to the house across here, and there is a line going into the ground. The line going into the ground represents the electrical grid supply, Iberdrola, Endesa, etc. You can also see that those lines are green, which means they're active and live, and if you look closely you will see there is a white dot moving along the lines that indicates the flow and direction of flow of electricity. So in this instance, from the panels, as you'd expect, to the inverter, from the inverter to the house, and any surplus, as you can see, is being sent down to the virtual battery. You also have the circle and the two boxes here and here. The circle represents the electricity that is being produced by your solar panels. And at this time, this client is producing 3.48 kilowatts of electricity from his panels. It's just changed to 4.11. It's updated itself. So as you can see in real time, the system will keep an accurate tally on exactly what is being produced. This electricity is being sent down to the inverter and across, as mentioned before. And we can see down here, the consumption within the property at this time is 0.13 of a kilowatt, 130 watts. Therefore, by default, there is 3.98 kilowatts being sent back at this time to his virtual battery. These numbers are all dynamic. What I mean by that is they will all change in conjunction with each other, depending upon the amount of energy being produced and the amount of energy being used. If we then go down further, you will see there are two numbers here. Statistics. That will give you a running tally during the day of how much electricity your system has produced overall, regardless of where that electricity has gone, whether it's gone to the house, whether it's gone to the virtual battery, or a combination of both. And today, Tom has produced 10.76 kilowatt hours of electricity. That's 10.76 units of electricity as shown on your electricity bill. That will reset itself to 0 at midnight tonight and start to count the following day when the system comes out of standby. The revenue figures, due to the fact that there are a different number of tariffs available, we do not advocate using and we do not set up ourselves. If you feel that you would wish to include those figures on your app, then please contact the office and they will be happy to assist you programming those in. You'll also note that underneath we have our environmental benefits. These are a bonus, an add-on. So we can see that this system, since it has been installed, note, this is not for the day, this is since it has been installed, is 7.84 tonnes of coal have been saved at the power station. 9.3 tonnes of CO2 has been reduced into the atmosphere, and therefore the algorithm calculates that that means he has planted the equivalent of 13 trees. Very commendable. That completes the explanation of the first page real time. We'll now go on to the second page and I'll explain the historic values for you. To get to the second page, the historic page on the Huawei Fusion Solar app, please go to the circle and touch the screen. I'll be using the cursor, but you just touch the screen and it will bring up this information in front of you. To get back to your first page, please go to the arrow and click on the arrow and it will take you back to the first page, the real-time page. So, let's move to the second page, the historic page. Here we have various numbers, graphs and circles, and I will break this down into 3 sections so that you'll be able to understand, hopefully, what these figures represent. At the top here we have accumulators. So you will see there is the current month, the current year, and the lifetime of the system. So the current month being January. So far, this January, since the 1st of January to today, this client has produced 258.71 kilowatt hours. 258.71 units of electricity. This will continue to increase up until the 31st of December, whereupon it will reset itself to 0 and start to count for the month of February and March and so on and so forth. Exactly the same here for the current year. So, since the 1st of January, as it happens, when this app was produced, he has produced 258.71 kilowatt hours as per the current month. What that will do is continue to accumulate all through the year. At the end of the year, on the 31st of December, the system will reset that value to 0 and it will start to continue to count for the following year, in this instance 2026. The lifetime figure here basically never resets itself. That figure will continue to accumulate from the very day the system was activated and switched on, right up until, for whatever reason, the system is switched off and taken away, decommissioned, etc. So to recap, the current month, current year, and the lifetime of the system, the cumulative values. We now move down to the graph. It gets a little bit more sophisticated and involved here, so please listen carefully. On the vertical scale of the graph, you have power. On the horizontal axis of the graph, that is your timeline. Now, to recap, power on the vertical, timeline on the horizontal. We also see up here, we have various menus: day, month, year, and lifetime. That means, in essence, and watch carefully what happens to the graph when I click on month, you will see the figures have changed, and you will see that the legend now has gone to kilowatt hours. Still power, but it is not a real time aspect, it is an accumulative aspect. So kilowatt hours for each day through January up until today, 17th. Ditto for the year. If we click on the year, it will allow us to see the months of the year. And finally, the lifetime will be year on year. This installation was put in on November 2022. So obviously that's the reason the figures are so low there. 2023 a full year, 24 a full year, and 25 just the beginnings of. The other good thing about this app is that you can go back to, say, your year, and you'll notice here there is a drop-down diary date mode. If you click on that, you can then scroll down to, whoops, beg your pardon, to it's a little bit fierce, excuse me. In fact, I'll use there you go, 2023, okay. And you'll see it will show you all of the months for the year 2023. Going back to the day, it will always default back to today's date. Obviously, the timeline in day mode is midnight until midnight. This hasn't actually happened yet. You can see I'm recording this about 3 o'clock in the afternoon. So, for purposes of the demonstration, I'm going to use, again, the drop-down date. And I'm going to go down to the 1st of October 2023. So, not the middle of summer, a day in autumn. But I happen to know it was a Sunday, it was a sunny day, and it gives me a good set of figures to work with. So, click OK. There we are. Now, what we're going to do now is describe and explain the legend. The light green colour is the PV output. The red is the total consumption. And the dark green is consumed from the PV. That is, consumed directly within your property. And you and I have the facility to be able to turn those colours on and off as necessary. So, my intention is to reintroduce each colour, explain the specific colour and what it means, and then build a total picture for you of what's going on with your solar system on any particular day. To begin with then, PV output, light green. You can see here about 8 o'clock-ish in the morning, the system comes out of standby when the light level has reached sufficient to activate the system. As the sun moves round onto the panels and becomes more directly perpendicular to the panels, that is when you will get your peak production from the solar panels. And then as the sun falls away, the production will fall away until such time at about 7:30 in the evening, at this date, the system will go back into standby. So again, total PV production, regardless of where that power's gone. I'll now turn that off and turn back on total consumption, which is actually what it says. From midnight through the morning, through the afternoon, to the evening, to midnight. At that point, the whole cycle will start again the following day. And as you can see, midnight up until about 8 o'clock, not really a lot going on as you'd expect. Then the client turns on an appliance. Because there's an increase in consumption of electricity, that will cause an increase on the graph, as you can see here. When the appliance is turned back off again, it will be recorded on the graph as it is on the next point, the next point, the next point. This large red area here would be when the client was using his pool pump. So as you can see, from about 11:30 till 3:30, this is when this particular client runs his pool pump, which makes very good sense. It's very important to use especially your high consumption loads during the day whilst your panels are producing the electricity. The third colour is consumed from the PV. Now watch very carefully what happens when I click on the consumed from the PV. You'll note that the red has turned to green on a certain part of the graph. That indicates that although the power was still being consumed within the property, that power has now come directly from the solar panels. Obviously, those outside of the scope of the panels, which are here and here, where consumption exceeded production, it'll be taken from the grid. You'll also see the red bits here and here, where again, because there's obviously no solar being produced at night, the power is taken from the grid, from the virtual battery, assuming that there is sufficient stored. So, if we now turn on the third colour, the green, you can see the whole picture. Power that is being consumed from the grid stroke virtual battery. The panels become live at around 8 o'clock, in which instance, as soon as they start to produce their electricity, Basically, they will supply the house, and any surplus will be going back, as shown on the green, to the virtual battery. You can actually look at this in landscape mode. If we go to full screen, click on. It's the only time the app will actually work in landscape mode. For the most part, it will normally only work in portrait mode. And you have the facility to zoom in, so you can specifically see at what times there were peaks of electricity being consumed, and perhaps adapt your lifestyle accordingly. To get back, we just touch on the arrow here, and it takes us back to where we were. The two circles here, the green and the orange circles, work in conjunction with the graph itself. You'll see it's titled Energy Management. Yield, again, was a alternative for solar panel production, alternative name for solar panel production. Consumption, self-explanatory. It's what you are using within the property. If you look at the circles, the totals that have been used and produced are shown in the center of the circle. So on this particular day, this particular client produced 30.91 kilowatt hours of electricity. He consumed during that day 13.94 kilowatts of electricity, kilowatt hours of electricity. So to recap, produced 31 kilowatt hours, used 14 kilowatt hours, rounding the numbers up. If we go across, you can see that 10.9 kilowatt hours came directly from the solar panels. Those figures match. That is this green area here, the dark green area here. The client took from the grid, from his virtual battery or from the grid directly, 3.85 kilowatt hours. These are these red areas here, the small peaks here, which I've explained, and then into the night and through. You'll note here this figure fed to the virtual battery. This client fed on this particular day 20.83 kilowatt hours of electricity back to his virtual battery for use at night or when the weather was bad, or if his consumption was outstripping his production. That is in essence 5 times what he took from the grid. 5 times. So you'll see in this instance, not only was all the electricity provided during the day, but during the night it was provided from his virtual battery, and there was a surplus of around 16 kilowatt hours stored into the battery for future use. That concludes the demonstration on the Huawei Fusion Solar app. I hope you found it of some use to you, and you can refer to it in the future should you need. On saying that, if there's anything that you'd like further details on or further explanation on, please contact our office, who will be happy to explain this to you, or if necessary, they will contact me and I will be in direct contact with yourselves. Thank you and goodbye.